Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over compound probability. So this first page, you were supposed to complete at least some of this on your own, trying to figure out if you can determine what the compound probability is for some of these scenarios. This first step, step 1, is just looking at singular probability, one event happening. So I wrote up here at the top how to figure out probability. The top number, it's always a ratio. So the top number is the number of favorable outcomes. So what are we looking for and how many of those outcomes are possible? And then the bottom number is always the total number of outcomes. Probability always falls somewhere between 0 and 1. So sometimes we'll represent them as whole numbers, as fractions, and then sometimes we'll represent them as percentages. So 0% to 100%. If you ever have a fraction that's over 1 or a percentage that's over 100%, you've done something wrong because that's not possible with probability. 0.5 is right in the middle, or 50%, that is as likely to happen as not. And then we use these words that determine whether things are likely to happen or not. If they're anywhere between 50% and 100%, that is likely. If it's anywhere from 0 to 49%, then that is unlikely to happen. So we use those words to determine the likeliness of an event happening. So let's go over these quickly. These are all just one event happening. What are the chances of landing on heads or tails? So either of those. So how many heads or tails is there on a coin? Well, there's 2. Out of how many total possible outcomes? Out of 2. So 2 out of 2, that is a 1 or a 100% chance of this happening. And what we say then, that is certain. It is 100% going to happen. What are the chances of drawing a 2 or a 5 from a deck of cards numbered 1 through 10? So we know there are a total of 10 cards. And then how many of them are a 2 or a 5? Well, there's 2 of them. And then we do always want to simplify probability, and we can divide both the 2 and the 10 by 2. What are the chances of rolling a 4 on a dice? So how many numbers on that dice are 4? There's 1 out of 6 total numbers. So 1 out of 6 chance of rolling a 4. Chances of landing on an A or a D. So we have 1, 2 that are A or D out of a total of 8 possible choices on the spinner. So 2 out of 8, again, we can simplify that further, and it is now a 1 out of 4 chance. What are chances of rolling an odd number on a dice? So odd number on a dice, we have a 1, a 3, or a 5. So there are 3 numbers out of 6 total numbers. So that simplifies again to 1/2, or 1 out of 2 chances. Chances of landing on tails when you flip a coin. So how many tails are there? There's 1 out of 2 possible outcomes. Chances of landing on C, A, or B. So we have 3 of those. Those are our favorable outcomes out of 8 total possible outcomes. So 3 out of 8 times we'll land there. Chances of rolling a 4. So we're just looking at a 4 on a 12-sided dice. So there is 1 4 on that dice out of 12 possible outcomes. So there, all of those are just singular probability using that definition at the top. So please fix those if you did not get those correct. This next part was then for you to kind of explore and try and determine a way to list out every possible outcome. So it says use a drawing, a diagram, or some other way of showing every single possible outcome. So this page was an exploratory activity. If you haven't done that, well then pause the video and see if you can create a list, create a picture somehow to show every single possible outcome for these 2 examples. I'm going to flip to the next page then, because they're the same problems, but now I'm going to show you 2 different ways that you could organize and list out all possible outcomes. The first being what we call a tree diagram. So what we do is take the first event that's happening. We've got 2 things going on. We've got flipping a coin and we've got rolling a dice. So the first thing, if we flip that coin, what are the possible outcomes? Well, we could either get a heads or a tails. And you'll see in probability, we often abbreviate those for H and T. So then let's say we do flip a heads. Then we roll the dice. What are the possible outcomes in rolling that dice? Well, we could get a 1, a 2, 3, 4, 5, or a 6. So here you can use then the tree diagram to see every single possible outcome. We have a heads and then a 1, a heads and then a 2, heads and then a 3. So we see all of them listed here, and you can see then that there are 6 possible outcomes when we flip that heads. Okay, next one then we have tails. Let's say we flip a tails instead. Well, then what are the outcomes when we roll that dice? They're the same exact outcomes, but instead we have the tails. So again, we can see 6 more outcomes, tails 1, tails 2, tails 3, so on. Here they are all listed out for us. So that's what the purpose of a tree diagram is. Now, the other way is we could use a table. A table is another way to just organize and see all possible outcomes. So here we have 2 columns because on the coin we could get a heads or a tails. And then we have 6 rows because on the dice we could get a 1, 2, 3, 4, 5, or 6. And then we could fill in this table by showing all those possible outcomes. And I'm going to abbreviate by showing we could flip a heads and roll a 1. Flip a heads and roll a 2. Heads, 3, and so on. And again, the purpose of these 2 things is to show every single possible outcome. And then once we have all those possible outcomes listed there, well, we can use it to determine our probability. So there are all possible outcomes. There is a word we use, or a phrase, or I guess a couple words here, sample space. The definition of sample space is showing all possible outcomes listed out. That is what a sample space is. So when we create a tree diagram or this table, well, that's what we're doing. We're figuring out that sample space. So now we can figure out the probability of this event. So we want to figure out the probability of flipping a heads and rolling a 6. So we're going to go through, and I'm going to double check. Yep, it was heads and a 6. So we could use our tree diagram to figure out, okay, well, here's heads and goes to 6. So there is one possible outcome for what we are looking for. Or we could use this table and go through and find where is the heads and the 6. So there's one favorable outcome, that is our top number. And then out of how many total possible outcomes, well, we could count them there, there's 12 possible outcomes. So 1 out of 12. Okay? Now, there is a second way to figuring out probability. The second way is to not use a sample space. So sometimes we may want to figure out what is every single possible outcome. But then sometimes, let's say we're dealing with a deck of cards where there's 52 cards in there. That's a lot of possible outcomes if we're maybe drawing a card from a deck of cards and rolling a dice. There's going to be 52 times 6, a lot of outcomes. So then instead, we would take the probability of each event. So the probability of flipping a heads, find that probability, then find the probability of rolling a 6, and we're going to multiply those 2 probabilities together. So the probability of flipping a heads, there's 1 heads out of 2 possible outcomes. Rolling a 6, there's 1 6 out of 6 possible choices, and then we multiply those 2 fractions. So 1 times 1 on the top is 2 times 6 on the bottom, and we figure out that the probability of this event is 1/12. Now, using that method, we don't actually see what are the possible outcomes. So that's what's important about the sample space. But if we don't need to know every single possible outcome, well, you could just use this method here. Probability of the heads times probability of rolling the 6, and you get the same outcome either way. The probability of that is 1 out of 12. Okay? Now, if you haven't had the chance, pause the video and try example 2. See if you could list out the sample space, list out every possible outcome, and then figure out what is the probability of landing on green and drawing a 7. So we could list out and make a tree diagram. So we have the spinner options are blue, red, green, and orange. And I'm leaving myself space because I know that the cards are numbered 1 through 9. So I know that if we spin a blue, we could then pick a card 3, 4 that are numbers 1 through 9. So I was leaving myself enough room, 7, 8, 9 to show every possible outcome. And this is, again, a tree diagram where we could see, okay, well, now we could spin a red and pick a card numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. We would do that with all of these spinning options. And the purpose here is also to try and make it organized, and my tree diagram may run into each other here, so I'm trying to keep it as best organized as I can. So then when we're done, we can see the total number of outcomes here. We've got 9 outcomes per color on that spinner. So we have 9, 18, 27, 36. So if we're finding the probability of landing on green and rolling a 7, well, the bottom number in our fraction is 36. Then how many of them are green and 7? Well, let's go to our tree diagram here with a green and then a 7. There's only one possible outcome in all of those outcomes that we listed there. So 1 out of 36 is our probability for this one. Okay? Again, I'm going to show you that second method where we don't have to list out all possible outcomes. We'd want to find the probability of spinning a green and multiply it by the probability of drawing a 7. So green would be 1 favorable outcome out of 4 possible choices on that spinner. There's 1 7 in those cards that are numbered 1 through 9, so out of 9. And then multiply straight across, 1 times 1, 4 times 9. We get 1 out of 36, which is the exact same that we found when we used our sample space of all of our possible outcomes. Okay, so that is how we use tree diagrams or tables to organize and show the sample space, all possible outcomes in a compound event. And then that's also how we find probability of compound events without a sample space, by just taking the probability of each event and multiplying them together. Now, again, I would like you to finish this packet or this assignment. So on the last page, there are a couple questions of what did you learn? So summarize some things that you learned today.